Hello, and welcome to your first hands-on experience with wireless sensor networks. In previous labs, we have used the Arduino to communicate with a remote XBee using the API mode. Today, we will use a Python program to interact with a remote XBee in API mode. This time, our computer will join the wireless sensor network and activate a remote actuator. We will use an LED as a simple actuator. You can use any other actuator in your project. Let's take a look at what we are going to need to complete the lab. You will need a breadboard, hookup wire, one LED, one USB A to B to power the Arduino, an Arduino board, two breakout boards, one XBee configured as a coordinator API. It is necessary to configure the API mode to 2 to communicate with the Python library. One XBee configured as router API mode 2. Two USB A to mini B to configure and power the XBees. And a computer. For doing this lab, we need a Python installed in our computer. Also, we need to download and install the XBee Python libraries. They will offer us an implementation of the XBee Serial Communication API. Finally, we make sure that the XBees are properly configured and they are in the same PAN ID. Verify that the two XBees are set to API mode 2. Now that we have everything needed ready, let's connect the hardware. We plug the coordinator API XBee into the XBee Explorer and connect it to our computer. We plug the router API XBee into the second XBee Explorer and connect it to the protoboard. We connect an LED between the D1 pin of the Explorer and the ground pin of the Explorer. The positive side of the pin is connected to the D1 pin. We finally connect the XBee Explorer to the computer to power the circuit. Now we are going to write a program that activates and deactivates the pin of the remote XBee. First, we import the necessary libraries. Note that we use the XBee library. Then we initialize the serial port with the COM where we connected the coordinator XBee and create a ZigBee object. At this point, we jump into the loop that will blink the LED. Then we send a command that activates the D1 pin. Note that we use a broadcast address, and therefore, if we had more XBees, they would all receive the command. Then the program waits for 5 seconds. And finally, it turns off the remote LED by using a parameter 4 in the D1 pin. Let's run the code. And enjoy the computer-controlled blinking of the remote LED. As mentioned before, if you have more XBee router modules at the same PAN ID, they will also receive the broadcast packet and start flashing. Now, we will change the code for sending packets to only one specified XBee, instead of sending broadcast packets to all of them. The only thing we have to change is the dest address long value. We have to replace the broadcast address for the destination XBee address. Now you can see that only one XBee is receiving our packets generated by the computer. Let's make things a bit more interesting by looking for the confirmation sent by the remote XBee when it receives a packet. We will modify our code to see how long it takes to receive an acknowledgement from the remote XBee after sending the AT command. We will need an additional library, datetime, to keep track of the time, and two new variables called tstart and tend that store the time at which we send the packet and the time at which we receive the acknowledgement. All we have to do is to print the difference between these two variables to compute how long it takes to receive the acknowledgement. Let's try our new program and obtain some measures. As a last step for today, we will learn how to send data to a device connected to the remote XBee. All we have to do is to replace the XB send function, indicating TX, and the data we want to transmit. In this case, we are sending a 3. Let's run the code. Right now, there is no one connected to the remote XB and listening to this value that we are sending. We could connect an Arduino to the remote XB that uses the Arduino XB library to communicate with the remote XB in API mode. This Arduino could read this 3 that we are sending and blink an LED 3 times to show that it has actually received the packet. Consider it a challenge and tell us how it goes in the comments.